Hello guys, today we're going to be working on proving some identities. So this will be for you guys' worksheet, the labeled Trig Identities worksheet 3.4. I got this worksheet from the internet, so for us it's really 5.1, but don't worry about that. This one is going to be due on Monday. So let's get into it. So the first one asks us to prove each identity, right? So if we're proving the identity, we want to prove that this left side is equal to this right side. So we're going to want to work with these equations, these expressions rather. We want to work with them and manipulate them so that this left side and this right side end up being the same thing. That way we've proved that this left side equals this right side. So you'll see what I mean here in a second. First off, what I'm going to do to make this easier for myself is I recommend always changing any of these ones, secant, tangent, 1 over secant, whatever it is. I want you guys to write it in terms of sine and cosine. That will help us, right? So we want sine and cosine. Those are our easiest things to work with, the most basic ones, right? So secant, we can write it as 1 over cosine of x. Minus sine, recall, is tangent of x, recall, is sine of x over cosine of x. And that's being multiplied by sine of x. Equals 1 over secant of x. Using your handout, we see that that is equivalent to cosine of x. Okay? So now we want to subtract fractions, but first I need to do this multiplication. So I'll leave this 1 minus cosine of x the same. I'm going to leave it. And then we have sine times sine, so that's sine squared of x over cosine of x. And the right side, we'll just leave it the same. Okay, so now that our denominators are the same, then and only then can we add or subtract our fractions. So remember, our denominators have to be the same to add or subtract fractions. So that'll give us 1 minus sine squared of x over cosine of x equals cosine of x. So remember guys, we want this left side to equal this right side. So how can we do that? Well, on your paper, under Pythagorean identities, we have this identity. Sine squared of x plus cosine squared of x equals 1. So at first it might not seem relevant, but in a second you'll see what we're doing. So I'm going to subtract sine squared of x from both sides of my equal sign. That's going to give me, it's going to leave me with cosine squared of x on the left side of my equal sign. And on the right side, I'll have 1 minus sine squared of x. So now, I want you guys to notice where it's tying in. We have our 1 minus sine squared of x, and we have our 1 minus sine squared of x. It's the same thing. They're equivalent. So, instead of writing 1 minus sine squared of x, instead we can write, what is 1 minus sine squared of x equal to? Cosine squared of x. So instead we're going to write cosine squared of x. I'm going to leave everything else the same. So that's going to be over cosine of x equals cosine of x. And finally, cosine squared of x divided by cosine of x is cosine of x. So boom, we've done what we set out to do. Our left side is equal to our right side, and henceforth we have proved that secant of x minus tangent of x times sine of x is indeed equal to 1 over secant of x. So we just proved it by showing that this left side, through a series of manipulations, is equal to cosine of x. This right side, through a series of manipulations, is equal to cosine as well. And these sides are both equal to each other. So this, all of this on the left side, equals this on the right side. Okay, let's move on to number 3. So we want to prove that secant theta times sine of theta, we want to prove that secant theta times sine of theta over tangent theta plus cotangent theta is equal to sine squared of theta. So this problem is basically, when I look at it, it looks like a big mess. So we're going to see what we can do with this problem. I actually have not solved this problem ahead of time, so I'm going in real time. So you guys will get kind of an insight of how I think through these problems, right? So first off, secant theta. I told you guys a good first step is always to convert everything to in terms of sine and cosine. So secant theta is 1 over cosine theta. And that's being multiplied by sine theta there on the top. So right here, what I've written so far, that's our numerator. That's all over tangent theta plus cotangent of theta. That's sine theta over cosine theta plus cosine theta over sine theta. So what I did there is I wrote that tangent in terms of sine and cosine, and I wrote that cotangent in terms of sine and cosine as well. Right? So far it's still looking like a mess. I'm going to go ahead and drop down that sine squared of theta. So what can I do here? So we'll try something, right? When you're lost, just try something. So what I'm going to do, I'm first going to erase all these arrows. What I'm going to do is multiply on the bottom so that I can add my fractions, right? Since I have different denominators, I want them both to be the same. So I want my denominator to end up being cosine theta times sine theta. So I'm going to multiply this side by sine theta on the top and the bottom. On the right side, I'm going to multiply by cosine theta on the top and the bottom. That will give me, let me rewrite everything, and let me get that in black as well. 1 over cosine theta. Oh, well, let's simplify the top. Sine theta times 1 is sine theta over cosine theta. That's the top. That's what I had up there in red. So let me highlight it for you in red. Our denominator will be sine theta times sine theta is sine squared of theta over sine theta cosine theta plus cosine times cosine is cosine squared of theta over, once again, sine theta cosine theta. So let me make this line a bit bigger so it's clear we have one big fraction. Okay, so On the bottom here, we can combine these fractions. So let me first move over on my work so I can have more room. Okay, I'm going to take all this and I'm going to continue up here. So on top we have, let me leave it as tangent theta. We might want to turn it to tangent theta, or I might regret it and I might actually want to leave it as sine over cosine, but we'll see. It's just a process, guys. You guys can't be afraid to try things. So on the bottom we have sine squared plus cosine squared of theta over sine theta cosine theta. So Pythagorean identity right there, sine squared plus cosine squared, that whole thing equals 1. So I have tangent theta over 1 over sine theta cosine theta. Or tangent theta times, remember when we divide by a fraction, so tangent is being divided by a fraction. When we divide by a fraction, we multiply by its reciprocal. So since I have tangent theta divided by the fraction of 1 over sine theta cosine theta, I'm going to multiply instead by its reciprocal. So that's going to be sine theta cosine theta over 1. But since it's over 1, we don't have to write it. So let me convert that tangent theta back into sine and cosine. I told you I might regret it. Times sine theta times cosine theta. What we notice, these cosines, since we have 1 in the denominator and 1 in the numerator, they cancel out. And that leaves us with just sine squared of theta. Right? And what did we want to prove, guys? Keep in mind that this on the left is equal to sine squared of theta. So all this time, we've just been working with whatever's on the left. So this whole thing on the left, we said through all this is equal to sine squared theta, which indeed was what's on the right. So we proved that whatever is on the left is in fact equal to what's on the right.